Welcome back. So in the previous video, we discussed about the properties of instantaneous center and the instantaneous methods or parameters to consider for an instantaneous center methods. So in this video, we're going to discuss about the Arnold's Kennedy theorem. So is Arnold Kennedy's theorem. In this, we're going to discuss about the how we can able to consider a number of instantaneous center for an different points. So now in this video, we're going to discuss about the Arnold Kennedy's theorem. Yes, Arnold is an Arnold name as an Arnold Kennedy. So he has proved that theorem that if all the bodies that is about the instantaneous centers will lie on the straight line only. So he has conducted a research and he has proved that. So that is about the instantaneous centers and all the instantaneous centers will lie on the straight line. Now we will see about the statement of the theorem and what are the conditions or what are the parameters for that instantaneous center method. So first we're going to see about the Arnold Kennedy theorem that is the Arnold Kennedy theorem states that if three bodies moves relative to each other, if three bodies moves relative to each other, they have three instantaneous centers and lie on straight line. See what the Arnold Kennedy's theorem states that if the three bodies move relatively to each other, if the three bodies moving relative to each other, then they have a three instant. Then automatically, if the three bodies moving relative to each other, then automatically it will be having a three instantaneous centers. If it is having a three instantaneous centers, then automatically all the three instantaneous centers will lie on the straight line. That is what the Arnold Kennedy theorem states that. So it will be mostly in the all the instantaneous centers will lie on the straight line only, right? So that is what the statement of the theorem. Now considering the three kinematic links A, B and C, which will be having a relative plane motion, considering three links, that is A, B, C, having a relative plane motion. So that is we should able to know that relative plane motion. So now the number of instantaneous center is given by. So when we considering a three kinematic links, that is ABC, which is having a relative plane motion, then the number of instantaneous centers n is given by, then the number of instantaneous centers n is given by, where n will be equal to, the formula to find out the number of instantaneous center was n into n minus 1 divided by 2. So the small capital N indicates the number of instantaneous centers, and where small n indicates the that is the number of links, where now when you consider this Kennedy's theorem, n will be equal to n into n minus 1 divided by 2, where n is number of links is 3, because having a three bodies which have been a relative motion to each other. So if I am going to substitute 3 into 3 minus 1 divided by 3 divided by 2, 3 minus 1 2, 2 into 3 6, 6 divided by 2, again it will become a 3. So what the Kennedy's theorem is tell, if the three bodies will be moving each other, then the three instantaneous center will lies on the same center. So we have been considering the three kinematic links and we got the number of links, that is number of instantaneous centers also will be 3. So now we will see that how it has been proved that. So the two instantaneous centers at the pitch joints B of a B with A and C, with A that is the instantaneous center at point AB and instantaneous center at point AC are the permanent instantaneous center according to the Arnold Kennedy's theorem. See this instantaneous center AB and instantaneous center at point AC are the permanent instantaneous centers according to the Kennedy's theorem, because AB, BC and AC, see A, B and C, these are the three instantaneous centers. So the third instantaneous center IBC must also lie on the joining of instantaneous center AB and instantaneous center AC. So in order to prove this, let us consider the instantaneous center, that is instantaneous center BC lies outside the line of joining IAB and IAC as shown in the figure. We can able to see this Arnold Kennedy's theorem, that is instantaneous center at AB, instantaneous center BC, A to B, AB, BC and AC. So these are the three instantaneous centers. Now the point IBC belongs to the link both B and C. The point IBC, what is this IBC? So this belongs to both the B and C, which we can able to see the vector BC and vector BC, that is which is belongs to both the links. Now its velocity VBC must be perpendicular to the line of joining of IAB and IBC. So it will be the perpendicular to the line of both IAB and IBC. We can able to see IAB and IBC. Now when you consider the point of IBC and the link C, now considering the point of IBC and the link C, so the velocity VBC must be perpendicular to the line of joining IAC and IBC. So line of joining this IAC and IBC, so that will going to be considered to find out the velocity when it is perpendicular. When it is perpendicular to the joining of IAC and IBC. Yes. Now coming to this, now we can able to see this complete diagram, that is all the instantaneous three centers IAB, IAC and IBC. You can able to see this forms within a B, and this is a form of a link C, and this is an A. So we have any three links and a three instantaneous centers. So all these three links have been relative to each other, and we can able to see the three instantaneous center points IAB, IBC and IAC. So this VBC and VBC, both, that is IAB and IAC, that will forms as an Arnold Kennedy's theorem. Now we have been already discussed that the velocity of the instantaneous center is same. That the velocity of the instantaneous center is same, whether it is regarded as the point of the first link or the point of the second link. See, it is same, but we have been not regarded that whether it is a first link or the second link. Therefore, the velocity of a point IBC, where you can able to see, cannot be perpendicular to the both the lines of IAB. See, this IBC is not able to or cannot able to be perpendicular to both the lines of IAB and IAC and IBC unless the point IBC lies on the joining points of both the IAB and IAC. When if it is joining lines between the IAB and IAC, then automatically it will be the perpendicular. So thus the three instantaneous centers, see this all these three instantaneous centers, that is IAB, IAC and IBC, must lie on the straight line. When all these three instantaneous centers should lie on the straight line, the exact location of IBC, the exact location of this IBC on the IAB and IAC depends upon the direction and magnitudes of the angular velocity. See this location, that is IAB and IAC, mainly depends upon the directions of this magnitude and directions of the angular velocities of B, C and A. The angular velocities of B, C and relative to A. See this the location of IBC, what we are going to see this, the location of IBC and the line of IAB and IAC, this all these three mainly depends upon the directions and magnitudes of the angular velocities. So the which is the angular velocities of this B, angular velocity of B, angular velocity of C and angular velocity of A. So by complete this all this that depends upon the directions and magnitudes of this particular velocities, that is particular velocities of instantaneous center point AB and instantaneous center point AC and instantaneous center of BC. So this, if the conditions, all these conditions, if it is satisfied, then the Arnold theorem, what is that, it can able to be proved that all the instantaneous centers will be lie on the straight line whenever these three instantaneous centers will be laying on the same straight line, that is it should be in the same straight line, and the exact location of IBC and IAB and IAC depends upon the all these three instantaneous centers direction depends upon the magnitude of the angular velocities of mainly this B, C and with it should be relative to the A. Then only this all the instantaneous centers can be will be lay on the same straight line. So this is how the Arnold Kennedy's theorem has been proved. So to find out the number of instantaneous center n will be equal to n into n minus 1 divided by 2. Based on this, we can able to find out the number of instantaneous center or number of links. So this is how the Arnold Kennedy's theorem has been proved. Thank you.